Hello, students. We are going to do our second day with partial fraction decomposition. The goal today is to write the partial fraction decomposition of the given rational function. So our goal is to break this up into two fractions that are added together, and both of them will have some form of polynomial in them. So what do? I kind of preloaded some of this work here, but the first step is we're going to factor the denominator. Now notice we got 3x squared plus 7x plus 4. Factor it whichever method you know how, but a lot of Tartan students end up using the box method. So we put 3x squared plus 7x plus 4 right in the diagonal. Multiply the corners to give me a positive 12x squared. And the factors of positive 12x squared that add up to give me the circled term of 7x is 3x and 4x. So plug those into the two remaining corners and then factor. So if we go straight up and down, we have a factor of 3x. Straight up and down, we've got a factor of positive 4. If I go left to right across the top, they have a factor of x. And then left to right on the bottom has a factor of 1. So we factored the denominator into the two pieces. The next thing we're going to do is we're going to rewrite that as, and notice I just factored the bottom here. So I've got x plus 8 over the original denominator factored. And then we split that up into a over the first factor plus b over the second factor. And it doesn't really matter which factor goes where. But notice, each one of these factors are linear pieces. So we just put a up top, b up top. If it was a little bit more, if it had a squared out here, we would have to change the way that we write this. We'll talk more about that on Thursday, Friday of this week. So the next step that we're going to do is we're going to take and we're going to multiply by the LCD. Now I think we've done a lot of this where this denominator that was completely factored is my LCD. So I'm just going to multiply every single fraction by the LCD. All right. Now, the next step, if you want to think of these as steps, is we're reducing. We're going to reduce out what do the factors have in common on top and on bottom. I've got a 3x plus 4 on top and on bottom, a x plus 1 on top and on bottom, and then here the 3x and the 3x plus 4 reduces out with the 3x plus 4, and then for b we get x plus 1 and x plus 1. So the third step is to write the remaining factors, and in a sense, what did we do? We cleared the denominators. The denominators are gone, and what's left over is an algebraic expression that has x's, it has the a and b that we're looking for, but now we're just going to expand. So we're going to distribute the a and the b to both terms. I have ax plus 1a, and then I get b times 3, so 3bx and 4b. Now, the way I like to think of it is somehow this right side added up to give me 1x. Well, what's being added together? It's the terms with the x's. And then somehow we got a positive 8 by adding the constant terms together. So what we're going to do then is we're going to separate those terms into two equations. I'm going to do one with the x values, and I actually kind of like to write, so I got ax plus 3bx, and that's going to equal x. And instead of writing x over on this side, I actually like to put it over on this side. And you'll see why when we turn it into a matrix. Then the next piece is I've got a plus 4b. That has to equal 8. Right? Now, here is my system of two equations, and we have two unknowns. We don't know what a is, we don't know what b is. So we're going to turn this into a matrix by just looking at the coefficients. So what are the numbers in front? And if it's just A, you can always put a 1. So I get 1ax, and I get 3bx, and then that has to equal 1x. And then I have 1a, I've got 4b, and I have 8. Now some people like to think of a dotted line here, because here's my values for A, here's my B values, and here's my numbers. Well, now we're going to go right to Desmos, our best friend Desmos, and you're going to go to desmos.com and select Math Tools, Matrix Graphing Calculator, or Matrix Calculator, and then we have to set up our new matrix. So I want to click New Matrix if it's not up there already, and I have a 2 rows and 3 columns. So rows go up and down, columns left and right. And then we want to just plug in our matrix 1, 3, 1. And then we've got 1, 4, 8. Right? Then hit enter. Now that will log A in, and I want to do the reduced row echelon form of matrix A. So I'm going to do hit the RREF of A, hit enter, and that will give us our actual, oh boy, my pen, that's all me, but let's try it again. Here we go. So this is the reduced row echelon form of our matrix, and I lost it there. I have 1, 0, -20. And then I've got 0, 1, and I believe it was +7. I'm going to double check that. Yeah. So I'm coming up on the end of this problem, but remember, what does that tell us? What do we know? Well, when A is 1, B is 0, or 0B, which means A equals -20. That's the number. And then what is the B? B is 1, and that's equal to the number of 7. So we figured out what A and B are. And to break this fraction up to break the original fraction up, we're going to just replace A with -20 and B with 7. So then my final answer is the original fraction can now be rewritten as -20 over 3x plus 4, because that's the way that I had it written, plus 7 over x plus 1. So I broke down the original fraction into the addition of 2 fractions. We decomposed it into partial fractions. All right, so let's try another one. We got 2 more we're going to do. And at any point, if you want to pause this and work through it yourself, go ahead. All right, let's look at this one. So notice now we just have 4 up top, which is fine. It doesn't really make a huge difference. But I got x squared plus 8x minus 20. Factor the denominator. So this one is really quick. You could probably do this in your head. I'm looking for factors of -20 that add up to give me +8. Well, that's +10 and -2. And notice, then I have to multiply by the LCD, but I want to kind of split this up first. So we get x plus 10, and I can call that A because it's a linear factor, plus B over x minus 2. And notice this is a linear factor as well, so we put B. So I'm going to multiply everything by the LCD. Well, what is the LCD? The LCD is always going to be that factored denominator. So we're going to multiply each piece. I Probably am going to run out of room here, so I might rewrite this just quick. Okay, so I just rewrote this over here because I was going to run out of room. So what do we have? We have the 4 over x plus 10 times x minus 2. That was the factored form. And then we're going to rewrite each factor. They're linear factors, so each one will be over a single letter, a and then b. And now we're going to multiply by the LCD. So go ahead and multiply each numerator. Now, I bet you're wondering, do I have to write that every time? Are there steps I can skip? Well, the reason why we write this to every single piece is everything has to be multiplied by the LCD. And then that allows us to reduce out the common factors. Otherwise, if we don't write that out, the factors mathematically can't reduce. And then we're going to write what's left over. So we have 4 left over on the left-hand side. A times x minus 2 plus b times x plus 10. And hopefully you guys are feeling really comfortable with this now. Distribute the A, distribute the B. And then we're thinking, okay, well, if this is my long statement, well, what gave me the values? Now, this is kind of interesting because we actually have something that's kind of missing here. And we haven't seen this appear yet. So there's nothing wrong with putting a 0x, adding a 0x in front. The reason why is what allowed me to add up to 0x? Well, a and b, ax plus bx gave me the 0x. And then 4, how did I get 4? The constant terms, the ones that don't have the x, had to give me 4. So then we're going to write our 2 separate equations, one with the 0x, and I like to put that 0x on the other side. So let's take the ax plus bx equals 0. And then we'll take the negative 2a plus the 10b, and that's equal to positive 4. So notice the 0x, oops, this should have an x here. 0x, those are the yellow highlighted terms that added up to give me 0x. And then the 4 are the 2 green terms. So now we can think of setting our system of equations up and turning it into a matrix. So we're going to take the constants in front, which is 1, 1, 0, and then the constants in front, which is negative 2, 10, and 4. All right, and then we jump to Desmos. So all right, so Desmos, we need a new matrix with 2 rows and 3 columns. And we're going to enter in our matrix 1, 1, 0. And then we've got negative 2, 10, and 4. Hit enter. And then we want to do the reduced row echelon form of A. And ooh, interesting result here. If you look at this, we get 1, 0, negative 0.3 repeating, 1, 0, 0, 1.3 repeating. Or remember, those are fractions. If you hit this little button, you can see the fractions, and you really want them to be in fraction form. So decimals aren't really that friendly. So we're going to use the reduced row echelon form. That tells us our 2 answers. That tells us what is A, what is B, and what is the number. So I'm going to read this when 1A is equal to negative 1/3 and 1B is equal to 1/3. So then once you find A and B, you're almost done. You just got to make sure you go back and put them into your final answer. So I always like to write You can either write the original equation, or you might even be better to write it with factors on the bottom. But this fraction can be broken into, and we'll review this here really quick. A over x plus 10 plus b over x minus 2. But this isn't really friendly. I don't like that fraction over a fraction. And I just want to make sure that, okay, good. I did pick the right negative, I don't remember. So there's a better way to write these problems. And when you are doing delta math today, remember when you are dividing by a fraction that this is just the same as doing 1/3 times 1 over x plus 10, which when we multiply fractions, it's multiplying straight across. So you get -1 over 3 times x plus 10. And you could distribute, or you could just leave it like that. And same thing over on this side. This negative, or this 1/3 is being multiplied by 1 over x minus 2, and then multiply straight across. And this is as far as you need to take it to break down this partial fraction, or you could distribute the 3 for both of these and you get the same thing as well. Okay, so just don't be careful with fractions in the numerator. All right, so we got one last problem. I'm going to do this one fairly quick just so you guys can kind of get the gist of it. Notice it's very similar to the other two. We have to factor the bottom, put it in our box. We want to multiply the two corners, and I'm looking for factors of -2x squared that add up to give me -2x squared. Sorry, they add up to give me positive 1x. So that's a positive 2x and a minus 1x. Those are going to go into the corners. And then we want to look at common factors left to right, top and bottom. So hopefully you're really comfortable with that. Now what we have then is I've got the denominator is now split up as two factors, x plus 1 and 2x minus 1. And then we're going to rewrite that as this original fraction can now be decomposed into the addition of two separate fractions. So now my goal is to then figure out what's the LCD. Well, the LCD is the factor denominator of the original fraction. So x plus 1 times 2x minus 1. And we're going to multiply each piece by the LCD. And then we're going to go ahead and reduce out our denominators, or our common factors. So go ahead and reduce out your common factors. Hopefully you're going to kind of notice a pattern with this. The more you do, the more confident you can become. And what do we have? We got x minus 1 left over on this side. I have a times 2x minus 1 plus b times x plus 1. And then go ahead and distribute. I just call that negative a. And now we're looking for how did I get my x terms, right? Well, the x terms came from the 2ax plus the bx. And how did I get my constant term? That came from a minus a and a plus b. So we're going to write our two separate expressions. So I like to start with 2ax plus bx, and that has to equal the original x. And then if we do that with the minus a and the plus b, that's going to equal -1. And now we're able to set up our matrix. I have a system of two equations and two unknowns. Remember, we're taking only the coefficients. So 2, there's always a 1 right here. And then there's always a 1 in front of the x. And then I've got a -1, a positive 1, and a -1. And then grab your calculator. So grab your calculator. I made a new matrix. It's a 2 by 3 matrix. and I put in the 2, 1, 1, negative 1, 1, negative 1, and then we're going to do the reduced row echelon of matrix A. Hit enter, there it is, and now I want to turn that back into fractions, and then we're going to just write that out and identify our A, B, and C. Our A, B, and C. A, B, not C. All right. So we get 1, 0, 0, 1, and I already forgot what was there. We got 2/3 and negative 1/3. So this is a positive 2/3 and a negative 1/3. A, B, and my number. So A is 2/3 and B is negative 1/3. Now notice, these are fractions, which means 2 is in the numerator, 3 is in the denominator, and since they're originally in the numerator, then we can kind of write them without showing all this work. If I know that A is 2/3, I'm going to put the 2 up top and the 3 in the denominator. That's 2/3. And then it's just going to multiply by whatever the denominator of A is, which is x plus 1. So you don't have to go through and show why that works the way it does, but you can just write it like that. Now look at B. Well, B is going to be over 2x plus 1, but B is negative 1/3. Now here's what I might do. I'm going to put a 1 here, and I'm going to erase the positive and make it a subtraction. So that's where the negative 1 comes from. 3 is going to go in front, and then we're just going to put the factor 2x plus 1 right next to it. And we're done. All right. Enjoy.